Hello everyone, we're going to talk about the transformational form of a sine function now. So transformational form of a sine function, this is actually what it looks like. Y equals a, the sine of b bracket x minus c n bracket plus d. Okay, now let's recall. So let's go back to thinking about something we know lots about already. Transformational form of a quadratic function. Okay, so talking about vertex form is another name for that. You're all familiar with that. So y equals a bracket x minus h all squared plus k. Now let's talk about this quadratic function in terms of what are the transformations that are there. So a, remember, we've talked about this many times. A is the vertical stretch. And it's called a vertical stretch if a is bigger than 1, right? It's called a vertical compression if a is, if the absolute value of a, is greater than 1, which means bigger than 1 or smaller than -1. If the absolute value of a is less than 1. So if it's a fraction or a negative fraction in between 0 and 1. Okay. Next we have, so let's go over here to our transformational form of a sine function. You'll notice that we also have a. This does the exact same thing in a trig function as it does over here in a quadratic function. So this is our vertical stretch or compression. Vertical stretch if the absolute value of a is greater than 1, and vertical compression if the absolute value of a is less than 1. So in between 0 and 1, in between 0 and 1 on the positive side, or in between -1 and 0 on the negative side. Vertical stretch if bigger than 1 or smaller than -1. Okay, back here to our quadratics. We have, let's see what is red. We have h, which is our, we hopefully all remember this. Can you still see where I'm writing? Yeah, there we go, stand this up some. Where we have our horizontal translation. You can also call this the horizontal shift. You'll see some textbooks and some people use that. It's translation or shift. It means just moving everything horizontally, right or left. Okay. Horizontal translation. And K is the vertical translation. I'll use a different color here. Brown for this. Vertical translation or vertical shift. Of course, you can say that as well. Or vertical shift. And remember, that just takes the graph as is and moves it up or down, up or down. Remember, I would do this in class, up or down, up or down. For vertical shift, back or forth, back one side or the other. For horizontal shift or horizontal translation. Now, look over here with our transformational form of the sine function. We have x subtract a number c. Over here it was x subtract h. It represented our horizontal translation. It's going to do the exact same thing over here. We're just using the letter C. We could use whatever letter we wanted in there, but our textbook uses this. So this is our horizontal translation. So that's going to take that sine wave, it's going to take that wave and just move it to the right or the left. And D is plus D out here by itself after the bracket. Back here also, plus K out there by itself after the bracket was the vertical shift, vertical translation. D is the same thing over here. So that's going to take, that's not doing very well. Sorry about that. Let's back that over. Vertical translation or vertical shift. Okay, and that'll be D units, up or down. So taking that wave and just moving it up or down. Everything goes up or down. All right, so you may notice that that's all the transformation. Oh, I forgot one, didn't I? Reflection. Okay. So reflection, black, I guess. Reflection, if A is negative, there's a reflection in the x-axis. And the same thing over here. If A is negative, that's an arrow. If A is negative, there's a reflection in the x-axis. Okay. Now, you'll notice that's all the transformations there is over here with quadratics. We have the reflection, the vertical stretch or compression, horizontal translation, vertical translation. Or we have over here in the sine function, we have all of those same transformations, but we have one additional transformation, and that is our b. Okay, so the b right here, this guy. So what does that b do? Well, it changes the period. So that's the horizontal stretch or horizontal compression. Okay, horizontal stretch or horizontal compression. So that's called the horizontal stretch or horizontal compression. And we're going to figure out more about this later. Whoops, compression. It's actually opposite of the vertical. If the horizontal number, if b is bigger than 1, then it's going to be a compression, okay, because we always look at the horizontal ones as 1 over that amount. And the horizontal stretch, if that ends up being a fraction. We'll talk about more precisely. There's a formula that we can use. Period equals 2 pi divided by b. So 2 pi divided by b will always tell us the period. So let's just think about that for a moment. With y equals sine x, the b is equal to that number that we don't actually need to write down, 1. So b is equal to 1 in this case. So for y equals sine x, the period is 2 pi over 1, so which means the period is 2 pi. And we saw this in our the previous videos where the period actually was the length from the origin to 2 pi, so the period is 2 pi. All right, that's transformational form of the sine function. Have fun with your investigations, and you might want to revisit this video at the end of doing those 3 investigations so that this sort of wraps it up for you again and makes more sense. Have fun.